In this example, it looks like you're finding the probability that in a group of 15 people that you choose the 6 youngest. So the probability that really what you're doing here is 6 choose 6 for the top, and there's only one way to pick the 6 youngest from 6. So there's no different combinations of the 6 youngest. Here, order doesn't matter, so use a combination instead of a permutation. And if you plug this in your calculator, or if you do the calculation of 15 factorial over 15 minus 6 factorial times the 6 factorial, this is dividing through the repeats of maybe you pick the youngest and the second youngest, versus you pick the 6th youngest and the 5th youngest or whatnot. This is the combination versus the permutation. So most calculators can do this for you, or you can plug this in your calculator and you get the 5005. On this example, going through, you have 19 horses that are available, and when you do NPR, out of the 19, you're going to pick 3 of them, and in this case, it's any group of 3. So in the example above, we were specifically looking at the group where we're grouping the 6 youngest, and there's only one way to do that. But there's 19 factorial ways, and in this case, we do a permutation because the order doesn't matter if I pick horse 1, 2, or 3, or if I pick horse 2, 1, 3. So without replacement, and this is the number of different ways we can do that. This number is going to be 19 times 18 times 17. So when we're looking at probability, so if we were talking about the bets, so there's 5,814 ways that we could arrange 3 horses from the 19 that are available. If I want to get a ticket for every one of those ways, or basically I'm going to have 5,814 tickets. So each one of them has a probability of 1 out of 5,814 for having the winning arrangement that are selected. So here they go through and look at what it would be to win that. So the probability you win times the amount of money you would get if you win, plus the probability you lose times the amount of money that you would bet. So I don't know if they have the solution in the book, but basically what you're doing here is looking at what is the probability of winning if you just pick 3 at random, and it's going to be 1 out of 5,814. Number 3.2.37, this formula is for standard deviation, and it's a little more complicated when you're given intervals. But here, basically, your frequency and then the value of your frequency, right? You're taking the sum of the frequency times the value of the frequency squared minus the sum of the frequency times the value quantity squared. And this is kind of going into a calculator. It can be kind of complicated here. Here's an example of the view an example. On this example, we are looking at the probability that out of 15, a group of 15, that we pick the 6 youngest students. In this example, this is a combination, and most calculators have a combination button somewhere on there. You can plug that in. If you don't have a calculator that does that, you can say that's 15 factorial over 15 minus 6 factorial divided by 6 factorial. And that's going to be 15 times 14 times 13 times 12 times 11 times 10 over 6 times 5 times 4 times 3 times 2 times 1. And you get the 5,005. The numerator here is the probability of, out of the 6 youngest, you're choosing the 6 youngest. There's only one way to do that. There's only one way to pick 6 out of 6. But the bottom is the total number of ways you can group 6 from 15, and you get 5,050. This next example in your textbook is you're looking at a horse race in which you pick 3 winning horses out of a total of 19 horses. So you're picking them without replacement. The number of different sequences and the arrangement is found as a permutation. So here your formula is n factorial over n minus r factorial, and this is basically 19 times 18 times 17. So the probability you get the first horse that wins, second horse, and third horse that wins out of 19 total horses. So you would have 19 times 18 times 17. That tells you there are 5,814 different possible arrangements. So if you want to know what's the probability of picking one of those arrangements, there's only one arrangement of picking those horses that all 3 of them win. And that's going to be 1 out of 5,814. And you could think of that as, like we said before, 3 permutate with 3. And that's going to be 1. So 1 out of 5,814. They all have an equal theoretical chance of winning. In statistics, however, in the real world, you have to be careful because the chance of winning is not going to be equal, and that's why they will put some kind of payout. It'll be something like 5 to 1 or 1 to 5, right? For every $1 you bet, if that horse wins, you will get $5. And there might be a ratio of 1 to 2. So this horse is more likely to win versus this horse, but if this horse wins, it's a bigger payout. So there's, in game economics, there's, those odds are kind of built in so that people will more likely put money on it, so that if they do win, if they invest $1 and they're going to win $5 for every $1 and they invest. This 3.2 measure of variation, this formula might look a little bit tricky because we're looking at an interval and a frequency. So the first thing in the interval is you need to find the midpoint, and that's going to be the value. N is the number of data points. So whatever you have, the 35 plus 29 plus 8 plus 3 plus 8 plus 2 plus 1, that's going to be N. Frequency was how many times they show up, and that is kind of represented here by the F, and the X value is going to be the midpoint. Your book goes through an example of this. If you click on the view an example in this homework, you can see the first thing they do is they find N, and in the interval they find the midpoint, and you can find the midpoint by taking the bounds divided by 2. So in this case, 40 plus 49 divided by 2. So 40. That would give you the 44.5 and so forth. So this is your class midpoint. That's going to be your X value. Your frequency is going to be whatever numbers in that column. So here the sum of the frequency times X squared. So frequency 1 times X1 squared plus frequency 2 times X2 squared. And you can see setting this up, there's a lot of buttons to push in your calculator. If you push this button here, you're able to copy or paste it into an Excel document or in StatCrunch, and you can actually have the program do these calculations and then sum them up. So in this part of it, we're taking the frequency times X and then squaring it. So the frequency times X is given here, we're adding it all up, and then we're squaring it at the very end. So if you're using your calculator, this is pretty tedious, and that's why it's beneficial to use a Excel file or a StatCrunch, and it can do this relatively quick. And a lot of them have built-in functions for examples like this. Looking at the z-score for 3.3.9, so it looks like maybe you did some calculations over here. It looks like you have it set up correctly, that the z-scored equals x minus the mean over the standard deviation, depending on S or sigma, depending on if it's a sample or a population. In this case, we're looking at a sample standard deviation, and we're looking at to find a z-score for -2. So we're looking for a range. Consider a value to be significantly high if it is greater than or equal to 2. So a test is used to assess the readiness for college. The mean test score was 20.4 and the standard deviation is 5.2. Identify the test scores that are significantly low or significantly high. So we're looking for, you want to find the -2, and we also want to find the 2, and you have x minus 20. I'm going to just say 4. Go ahead and look at the one you did. It must have been these numbers here. So I'm going to just keep with that. So to solve this, you're going to multiply both sides by 4.5, right? And looks like you did that. And when I do it on this side, it cancels. So I shouldn't have had a 4.5 over here. So 4.5 times -2. So that gives me the -9, right? And then on this side, you have, instead of this, you have x minus 20.2. So -9 equals x minus 20.2. So if I add 20.2 to both sides, -9 plus 20.2, that would give me 11.2 would be x. And if you do the other way, you would have 9 equals x minus 20.2. So basically 9 plus 20.2. So what this is also saying is you have the mean here, x bar is 20.2, and you know a standard deviation is 4.5, right? So if you want to go 2 standard deviations, you're going to go 20.2, subtract 4.5, subtract 4.5. So you're subtracting 9, so 20.2 minus 9 gives you 11.2 as the low end. And if I add 9 to 20.2, that's going to give me 29.2. So this would be the low end, this would be the high end. And you can see that the middle is 20.2. If I go standard deviation, 2 standard deviations, right? This would be a z-score of 0, this would be a z-score of 2, and this would be a z-score of -2. So hopefully that kind of shows, I'm not sure algebraically what went on here. You definitely can use this formula, but you can also kind of draw the picture to see. I have the mean. If I add 1 standard deviation, I'm adding 4.5. If I add 2 standard deviation, I'm adding 4.5 twice. Same thing with the other direction. So hopefully these answer some of your questions. If you have any other questions, please let me know.